Cable carrier chains are very common in machine design, but normally you don't see them as an accurate representation of how they would move within the machine parts moving. Some designers do take the time to at least show the start and end positions of the chain, but wouldn't it be better to have them move properly, especially if you want to make an animation? Well, in this video I'll teach you how to achieve this. First, we need to build a new assembly with the ends of the chain and one of the chain links. For now, just locate the fixed end in a specific position within the assembly file. I suggest having the pivot concentric to the origin of the assembly file, while at the same time having the fixed ends symmetric with the front plane. Now make the end fixed so you use less mates, even delete the previous ones if you like. Next, mate the first link to the fixed end using a concentric mate, a coincident mate, and I also suggest a parallelism too. For now, the movable end will remain floating, but we do need it to be aligned to the other end, so here you can add another coincident and parallelism. The next step is the most important one. You need to create a part file that only contains a sketch. Preferably do this inside the assembly so you build a virtual part within it, or create a part file first, then add it to the assembly and next make it a virtual part. As for the sketch, draw this shape with all the proper relations, then activate the View Dimension Names button inside the Hide All Types drop-down menu. Now, define the chain radius and a quote-unquote chain length. These will be adjusted to your needs for later. Add some names to these two new dimensions so we can identify them better later. Next, go to Tools, then Spline Tools, and look for the Fit Spline option. Uncheck the Closed Spline checkbox so the sketch doesn't close and click OK. Now, when you select one entity of the sketch, everything will be selected too. This will come in handy later. Go back to the assembly and locate the sketch part. One of the lines has to be aligned with the origin of the assembly, or more precisely, one of the lines has to be aligned with the pivot of the fixed end. So I'll mate the top plane of the sketch part to the assembly top plane to always ensure this alignment and also a coincidence between the two midplanes. The sketch file should only be able to move in one direction, the direction of the chain's stroke. Now for the good stuff. In the assembly tab, locate the chain pattern feature. Here, choose the last option under the pitch method section. Only with this option you'll get a realistic chain behavior. For the chain path, choose the sketch inside the sketch part. For this to work, all the sketch has to be selected. Next, choose a number of links. I'll start with 20. Then, in chain group 1, select the first link, and as for the next two faces, select one of the cylindrical faces that represent the connection with the end part. And for the other cylindrical face, choose one of the two faces that connect with the next link. Finally, for the path alignment plane, choose a proper midplane. If you don't see more yellow links, you probably have the pattern direction reversed, so go back to the top and reverse it. You may need to create a midplane for the link part for this to work properly. One last thing though, if you want the chain to move, then keep the dynamic button on all the way below in the options section. Otherwise, select static. Having the chain built, add a concentric mate between the last link and the movable end, and this should move properly. At this point, you should know the distance between the end faces and of course the way the chain will be fixed in place. That is to say, if the ends will be opposite or aligned. In my example, the ends have to be aligned and be separated by 250 mm. Depending on the design of the end pieces, the distance between the pivot center and the face that will be in contact with the other part where the chain will be fixed in place will vary, and this will be very important if the end pieces are opposed. In order to adjust the dimensions of the chain, you can edit the sketch dimensions directly in the sketch part file, but that's not fun. Another method to quickly edit the sketch dimensions is via assembly equations. Go to Tools and look for Equations. Now create two global variables, one for the end-to-end height and the other for the chain length. Now, under the Equations components, add a new equation. Open the sketch of the sketch part, and double click it so you can see and select one of the variables of the sketch. Here's what you need to remember. In order to ensure the distance between the end parts that you need for a parallel configuration, you just need to divide by 2 the value of the end-to-end height. For an opposite alignment, divide by 2 the value of the end-to-end height and add the distance between the pivot center and the contact face of the end pieces. Also, create an equation that links the chain length global variable with the sketch length dimension. If done right, you can quickly update your assembly by just typing new numbers in the global variable values. If for some reason you decide to add or remove links, you'll need to update the concentric mate of the movable end piece and also the chain pattern. Now you're ready to insert this assembly inside the real assembly. Fix it in place and then make this assembly flexible. In this assembly, which you can download from GrabCAD, link in the description, the shape of the chain is linked to the stroke of this pick and place mechanism. So if I move my mechanism, which already has a limit made, my chain should follow. So why do this? Well, mostly for show, but this can help you to determine the number of links you'll need to, or predict and prevent collisions. This comes at a cost though, as having the assembly update constantly will require a little more resources. And that's it. I hope you found this useful. Now go and show your boss and co-workers your new trick and blow their minds. If you found this useful, leave a like and consider subscribing for more SolidWorks unique tips and tricks. And if you have a problem that you don't know how to solve in SolidWorks and would like to see in a video, then leave it in the comments down below. I'll be seeing you fellow designers. Remember, work smarter, not harder.